Let's understand motion in this video. Have you seen a butterfly flutter, a ball fall, or a car run on a straight road? All these are examples of motion. And scientists first study simple kinds like straight line motion and circular motion. Motion in a straight line is called linear motion. For example, a swimmer in a lane, a ball dropping, or a train on a straight track. To describe where an object is, we pick a fixed point called the reference point or origin. O. The position of the object is its distance and direction from this origin at any instant of time. An instant of time is just a single clock reading, and a time interval is the time between two instants. In straight line motion, we use plus and minus signs to show direction. Usually, right is plus and left is minus. Distance is the total path length an object travels and is a scalar. It needs only a number. For example, Ramesh traveled 65 kilometers. Displacement is the shortest straight line distance from start to end and is a vector, so it needs a number and a direction. Displacement can be positive, negative, or zero, and it can be smaller than or equal to distance. For example, if you run around a circle and come back to the start, your distance is the whole path, but your displacement is zero. Look at an athlete example. He runs from O to B, then to A, and back partway to B. Total distance was 160 meters, while net displacement from start was 40 meters in the positive direction. Another example. Someone goes 4 kilometers north and then 4 kilometers to the right. Total distance is 8 kilometers, while displacement is the straight line 4 root 2 kilometers, about 5.66 kilometers. Uniform motion means equal distances in equal times, and the speed stays constant. While non-uniform motion means distances in equal times are different. Average speed tells how fast an object moves overall and equals total distance divided by time interval. For example, a car goes 20 kilometers, 40 kilometers, and 30 kilometers in 3 hours. Average speed is equal to 20 plus 40 plus 30 divided by 3 is equal to 30 kilometers per hour. Average velocity tells how fast position is changing and in which direction. So, average velocity equal to displacement by time interval, written as v underscore av equal to s by t. In a pool, if Sarang swims to the other end and back, total distance is 50 meters, but displacement is 0. So average speed equal to 1 meter per second and average velocity equal to 0 meter per second. Average acceleration describes how quickly velocity changes and equals change in velocity divided by time interval. In symbols, a is equal to v minus u divided by t2 minus t1, and its SI unit is meter per second squared or meter per second per second. If speed is increasing, acceleration is along the direction of motion. If speed is decreasing, acceleration is opposite to motion, called deceleration. As an example, a car going from 40 kilometers per hour to 60 kilometers per hour in 5 seconds changes speed from about 11.11 meters per second to 16.66 meters per second. So, A is equal to 16.66 minus 11.11 divided by 5, approximately 1.11 meter per second squared. Graphs help us see motion clearly by plotting position, velocity, or acceleration against time. To draw a position-time graph, draw time on the x-axis and position on the y-axis. Choose a scale, plot the points and join them to get a line or curve. A straight line sloping up on a position-time graph means constant velocity. A flat horizontal line means the object is at rest, and a curve means changing velocity. The slope of a position time graph gives the average velocity. V is equal to S2 minus S1 divided T2 minus T1. For example, if position changes from 0 to 25 meters in 5 seconds, average velocity equal to 25 divided by 5 equal to 5 meters per second. A velocity time graph shows how velocity changes with time. Its slope gives acceleration and the area under the curve gives displacement. For constant velocity, the area is a rectangle. For changing velocity, use area of a trapezium or triangle to find displacement. Example: a constant velocity of 20 meters per second for 6 seconds gives displacement equal to 20 into 6 equal to 120 meters. Another example combining rectangle and triangle areas gives a displacement of 75 meters for a certain change in velocity. When acceleration is constant, 5 quantities s, t, u, v, a are linked by 3 kinematic equations. Equation 1. V equal to u plus at. Equation 2. S equal to ut plus 1 half at squared. Written: S equal to ut plus 1 half at squared. Equation 3. V squared is equal to u squared plus 2as. Written: V squared is equal to u squared plus 2as. These equations work only when acceleration is constant, and signs tell direction when motion is along a line. For example, a car starting from rest with A equal to 0.1 meter per second squared for 4 minutes, t equal to 240 seconds, reaches V equal to 0 plus 0.1 into 240 equal to 24 meters per second and travels second equal to 1 half into 0.1 into 2040 squared equal to 2880 meters. In another example, brakes giving A equal to minus 6 meter per second squared stop a car in 2 seconds. So initial speed u equal to 12 meter per second and the car travels 12 meters while stopping. Motion in a plane means movement in 2 dimensions, like a kicked ball or a satellite orbiting, and circular motion is a key case. In uniform circular motion, the object moves around a circle with constant speed. Distance along the circle is not equal to displacement along a straight line. For one full turn distance equal to circumference equal to 2 pi r and displacement equal to 0. So average speed for one revolution is 2 pi r divided by t, while average velocity is 0. Even if speed is constant in a circle, the velocity direction keeps changing. So the object is accelerating because direction changes. A simple test is a marble on a ring that moves straight when the ring is lifted. That shows velocity is along the tangent at each point. So, what do we learn from this? We learn how to describe motion using position, distance, displacement, speed, velocity, and acceleration. How graphs help and how kinematic equations predict motion when acceleration is constant. Let us quickly remember. Pick an origin. Distance is a scalar. Displacement is a vector. Average speed equals distance by time. Average velocity equals displacement by time. Acceleration equals change in velocity by time. Slope of position time equals velocity. Slope of velocity time equals acceleration. And area under velocity time equals displacement. Keep curious and try small experiments, like timing a toy car on a straight track or drawing simple graphs. If you want more clear examples and practice, gently explore the topic further on EduRev, where you can learn step by step. Well done for listening. Keep asking questions and keep enjoying science at your own pace.